All right, a little bit of golf applause. This is our very last page of notes that we've ever had. So everybody clap your hands. Good job, good job. We made it all the way from August to now. Okay, last page, we're going to work backwards with all three formulas that we have already looked at today. So before we jump into these, let's take a look at which formula would be applying to which situation. So on our first question here, we have how many sides in the polygon, how many sides are in the polygon that has 36 diagonals from one vertex, okay? That means that the formula that we're working with is our f of n equals our n minus 3, okay? So it's just going to be that first formula we did. On our next one, on this one, I know that there were 435 handshakes. So we know that this is probably going to be the handshake question, at where everyone shook hands with everyone else. And we can assume it was only one time. So we want to know how many people are at the party. This was the last formula that we did. So this was our f of n equals our 1/2 n minus 1 times n. Okay, so that's the one we need to work backwards on. And then our last one says how many sides are in the polygon that has the total number of diagonals. Okay, that was our second formula that we did. So this was our f of n and our 1/2 and our n minus 3 times our n. Okay, so these are the formulas. We first need to be able to identify what formula it is that we're trying to work backwards with. Now, first one's obviously going to be the easiest. What we know on this problem is that we know that the number of diagonals is 36. So that means that we've evaluated for some number and we got 36. So I put some number in for n and I got 36. I'm just working backwards on this. So I end up getting n equals 39 sides. That one is done. Just quick little algebra there. The next one is going to require a little bit of thinking or some algebra, okay? Personally, I prefer the thinking method on this one. I think it'll be easier for you to do. All right, so on the next one, we know that we've put in some number for n and we got 435 handshakes. So I have 435 handshakes when I plugged in some number for n to that equation. Now the first thing that I'm going to do is I'm going to get rid of this 1/2. So I'm going to multiply both sides by 2 and I'm going to get 870 equals n minus 1 times n. Now, as you're pondering how to solve that, some of you are thinking very concretely, algebraically, and what you're thinking is FOIL this out, so you get an n squared minus n, move everything to one side, either to the left or to the right, and then you could do your quadratic formula. And although that would work, it is not what I would suggest. Here's what I want you to look at and think about. When you look at this product, what I know is that the two numbers, I'm going to even cover them up here, these two numbers are very close to each other. In fact, they're only off by 1, which means 870 is almost a perfect square. So if it's almost a perfect square, what I'm going to figure out is what is the square root of 870. Now it's not going to be an exact answer. So if I figure out what number is the square root of 870, okay, I'm just going to poke it in my calculator here. If I do the square root of 870, see if I can make this show up a little bit better for you there. Okay, if I get the square root of 870 is 29.5. Okay, so I'm going to say this is about 29.5. Now, obviously, there's not a half person at the party, but that means that if I square 29.5, I'm going to get about 870. Now, I need this to be a whole number when I plug in something here. So what I'm going to do is I'm going to bump this up. Therefore, I'm going to actually test and see 30. Maybe there were 30 people. I know that my correct answer has to be very close to this 29.5. So it's either going to be 29 or it's going to be 30. So I'm going to bump it up and test 30. So if I take 30 and I plug it into my formula, okay, so I'm plugging it in right here. So if I say 1/2, and I'm going to do 30 minus 1, so that's going to give me 29, and then 30 goes in for my n, and I'm going to type that in my calculator and see what I get. So I'm going to do 0.5 times 29 times 30, and sure enough, I get 435. Is that how many handshakes were actually at the party? Yes. So since that's the correct number of handshakes from the party, then n must have been 30 people at the party. It's a big party, okay? Remember, can't have a half person. The other alternative, of course, is to distribute the n, move everything to one side, and factor or do the quadratic formula, okay? Now, our next one is going to be extremely similar, but you can tell they're not as close to being perfect squares as this one was. So on our handshake question, they're only off by 1. This one, they're going to be close, but not as close. So similar process, okay? Start out the same. This one, I know that I've plugged in a certain number of sides, and I got that there were 819 diagonals. So I'm going to start this off the same way that I did before. I'm going to multiply both sides by 2. I get 1,638 equals n minus 3 times n. Okay. Now, they're almost perfect squares, just farther off than the last time. So again, I'm going to do the square root of 1,638. We're going to poke that in our calculator here. And I get 40.5. Now remember, I can't have a partial side, so I've got 40.5. So I'm going to have to test a couple numbers, and through some experience, you'll kind of start to figure it out. So we're just going to make a list of potential numbers to test. So I'm going to test n equals 41. I'm going to bump it up. I'm going to test n equals 42, and I could potentially have to test n equals 43. I will probably get my answer before I get to 43. Most likely it's going to be this one, but let's just test and play first. So if I do n equals 41, I'm plugging into the formula. So when n equals 41, I'm going to have 1/2. 41 minus 3 is 38. And then, of course, my 41. Type that in my calculator here. I'm going to slide this up. It'll make it a little easier for you to see. So just type that in my calculator, 0.5 times 38 times 41. That tells me that there were 779 diagonals. Is that how many diagonals that we had? No. So that one fails. We mark it out. Test the next one. N equals 42. Let's test this. I have 1/2. 42 minus 3 is going to give me 39. And then 42. Let's type it in our calculator. 819. So, is 819 the number of diagonals that I had? Yes, it is. So, we must have had 42 sides in our polygon. And that is how you work backwards.